The final puzzle that we're going to be taking a look at here is something called a KenKen. There are other ways of saying this as well. I've also seen it called a Calcudoku, something like that. Calcudoku. I've seen that as well. Whether or not that's an actual name, I've definitely seen that. This one here is a little bit like a Sudoku, but it has a bit of a twist to it, and it has a bit of a way of making things easier or harder. So what we're going to be doing, or how we solve these ones, is first, it's going to have a grid kind of like a Sudoku, except that the grid is different size. So this one here is a 3x3, this one's a 4x4 grid, and based on the size of the grid, it's going to depend on which numbers we're going to be using. So if we have a 3x3 grid, we're going to be using the numbers 1 to 3. If we have a 4x4 grid, we're going to use the numbers 1 to 4. Just like, one of the things you might realize here is that instead of it having just 9 boxes or nine square boxes, this one has a bunch of heavily outlined groups, okay, and what we're going to call cages. In the upper left-hand corner of each cage, there's a target number. So something like this here, there's a number 1, and there's some sort of operation. Here we have the negative or subtracting. So what that means is that these two cells right here have to subtract to be 1. Okay, so either 3 minus 2 or 2 minus 1, and order doesn't matter. We could have the bigger one on bottom. It doesn't really matter. Just those two numbers have to subtract to get 1. Okay, and again, that's in any order. So again, same as a Sudoku, each row and each column must have one of each of the numbers. So in other words, this row, there must be the numbers 1, 2, and 3 in whatever order. And so that, so you can't have 2 1s or 2 2s or 2 3s or all 3 3s. You must have one of each, so 1, 2, and a 3 somewhere in this row, and in this column you must have a 1, 2, and a 3 in every single column as well. Now, to solve these, it takes a little bit of maneuvering both the rows and columns, 1, 2s, and 3s, as well as the operations that arise in there. So let's take a look at the first one here, and I'm going to use a pencil again because it's sometimes going to be handy to erase. And let's look at this first cage right here. We have these two that have to multiply together to get 6. Now, there's only a couple different options or ways to multiply to get 6. We could do 1 times 6 or 2 times 3. Well, this 3x3 does not have the number 6 in there. It only has 1, 2, and 3. So we know that these two right here must multiply together to get 6, and they must be the numbers 2 and 3. Now, we don't know what order it's going to be in yet, but we know that one will be a 2 and one will be a 3. What that means is if we look at this column, we know that these will be 2 and 3, and this is going to be our third value, which in fact must be a 1. Okay, has to be a 1 because these ones are 2 and 3. Okay, we don't know what this cage is going to be like yet, but we know that these two have to be 2 and 3, so this has to be a 1. On that note, okay, this cage up here, these two have to subtract to get 1, and the only number that we can subtract 1 from to get 1 is 2. 3 minus 1 would give us 2, so that doesn't work. So it has to be 2 minus 1, and so this has to be then a 3 because we have to have the numbers 1, 2, and 3 in whatever order, and we'll see that in just a little bit. Okay. Now, as we get each cage finished, we can kind of move on to other cages, and sometimes it helps us with certain ones. These two right here have to subtract to get 1 as well. 3 is already here, so we have to have a number that subtracts to get 1. Well, 4 would work or 2 would work. But the thing is, we can't use 4 because we only have the numbers 1 to 3. So this one will in fact be a 2. And that tells us that that one's a 1. Now let's go back to what we learned in this cage right here. And we knew that this had to be a 3 and a 2, but now we're told that this is a 2. So this one can't be a 2. This one has to be the 3, and this one has to be the 2. They'll multiply together to get 6. This one now has to be a 1, and this one has to be a 3 based on what we know from our rows and columns. 1 plus 1 plus 3 gives us 5. And so that, in fact, works out really nicely. Let's try one that's just a little bit more difficult. Okay, here we have a 4x4, meaning that we will use the numbers 1, 2, 3, and 4 to come up with that. And sometimes we might have to kind of help ourselves out a little bit. Two numbers that multiply together to get 3 are 1 and 3. Therefore, the two numbers that divide to get 2 have to be the 4 and the 2. Okay? These two numbers here multiply together to get 4. We could have 2 and 2, but that we aren't allowed to have two 2's in the same column. So this one has to be 4 and 1, and that means that this has to be 3 and 2. All right, so we're kind of trying to like eliminate some of our values there. Now we want to come up with two numbers that subtract together to get 2. So we could either do 4 and 2 or 3 and 1. Well, we know that one of either if this one or this one has to be a 4, and based on that, the other one's going to have to be a 4 here. So we can't have a 4 down here, so this has to be 3 and 1. Now, once we know that, this 4 and 1, we know that if these two are going to, if one of these is going to be 1, this one can't be, so then this has to be the 4, and this has to be the 1. On that same note, we then know that this has to be a 2, and this has to be a 4. Okay? So again, kind of going through and using reasoning to try to figure out what our answers are going to be. We know that now this will be either 2 or 3, and this will be a 2 or 3. Well, we can't divide 3 by anything to get 2, and there's nothing big enough that we can divide by 3 to get 2, so we know that this has to be a 2, and this one will have to be a 3. Okay? And that also tells us that this will then be a 1, and this will be a 3. Okay? So this one could either be a 2 or a 4, and we know that, and this will either be a 1 or a 4. Okay, so one of those will be there. And let's see here. That tells us then that if this is a 4, 2, so this one can't be a 2, so this will have to be a 1 or a 4, and this one then is going to have to be a 2 automatically. Okay, it's because either 2 divided by 1 will give us 2, or 4 divided by 2 will give us 2, and we know that it's got to be a 1 or a 4. Now we can start to fix things up here. So this has to be a 4. That means that this has to be a 1. This one has to be a 4. We know then that this has to be a 3, and this is then the 1. And because of that, this is a 3, and this is a 2. Okay, there's a couple different ways of solving it. Again, using little notes in there, you can definitely do that. Make sure that you are looking at each row and each column as well to make sure that there's no repeats inside. And you'll notice that I don't have any repeats inside, thankfully. That means that I probably did it right, and every one of my operations is going to work. Difficulty, again, is going to come in the size of numbers. You can get all the way up to a 9 by 9. Actually, I think you can get bigger ones, but 9 by 9 is a pretty nice size. And but for now, we'll deal with a bit smaller ones. If you want to look at bigger ones, I can get you some bigger ones as well. If you want to keep to the small ones, we can definitely stay to the small ones. I've given you 6 KenKens to do. Do at least 2 of them. Okay, do at least 2 of them. Sorry, I should say do at least 1 of them. If you get 2 done, that's awesome. Try the second one. If you get all 6 done, even better. And work through those and try to solve each one of those.